Okay, next up is for the fifth tutorial of demand elasticity. Okay, so this one is already explained in the previous tutorial, right? So the demand is the willingness to pay, which approximates the utility, which is which component of the demand, and it's the demand here, or the quantity of demand here is the function of price in the y-axis, and then the quantity is on the x-axis, and it decreases over the decrease of price. Then the demand function is a dependent relationship between the quantity of a goods or service purchased or consumed and its price. Then the relationship of in the demand curve above assumes certain outer variables influencing the relationship remain unchanged. And then if the travel time increases in volume or number, this is for the example, okay? People using a particular means of transportation, and if the price and service level of alternative means remain unchanged, the demand curve will shift downward to the left. The other variables influencing the demand function can include social factors such as population, income, and so on. I already explained this one before, so I just want to skip it. And then in this tutorial, we will uh, we'll do a lot of uh, explanation about the demand elasticity. So basically, it's not a direct elasticity actually, but sorry, it's not a direct change, but it's relative. It's not a direct subtraction or ratio, but it is actually the ratio of the relative change. Okay, so it's the ratio of the relative change of the demand. So this one, sorry, this one is relative change of the demand. So the change of the demand divided by the demand, and then divided by this one. Relative change in variable x, sorry, the change of the variable x divided by the uh, value of the variable x. So this one is relative and this one is relative. Then we get the simplified formula like this. And the x can be any variables influencing the demand. So this demand elasticity is a dimensionless measure that expresses the relative sensitivity of demand to change in variable x. So for example, if x changes by 1, the, the quantity will change by ax%. And then for the demand is called inelastic or low, or has low elasticity if the uh, absolute value of demand elasticity is between 0 and 1. So the elasticity value here can be negative, can be either negative or positive. So since this thing happened, we want to check for the absolute value, not the value. Okay. Then it's called elastic if the elasticity if is more than 1, and then it's called unitary elastic if the elasticity is uh, exactly equal to 1. Then the value is positive. If the value is positive, the change of x will yield to the change of will yield to the increase of x will yield to the increase of the quantity. And if it's negative, the increase of x will yield into the decrease of the quantity. This is just type of the demand elasticity. We have R elasticity and point elasticity. I don't want to go further into this because it's already explained in the class. And then the usual demand function form uh, here in this course they usually use the linear only to simplify the calculation, because if it's not linear, you need to calculate the the case in the previous tutorials, in tutorial 4, using integration, and it's a bit um, yeah, a bit complicated and difficult. Except for the demand elasticity, the types here includes direct elasticity, then cross elasticity. So basically, the direct elasticity is the demand elasticity for the choice of M with respect to the characteristic of that choice itself. So it's about the same mode we talk about the transportation. But if it's across elasticity, it's about a different mode. We can check about this later in the study case. Okay. So for the example of the formulation is right here. The elasticity of demand M due to change in cost N. And the alternative can be substitute, can be complement, or even independent. This upper part is means that the alternative is influencing each other. But if it's independent, it doesn't influence each other. The change doesn't influence each other. This for the example study case. So the change in daily volume of users of certain modes of transport as a result of change in the fare of a mode is known as follows. For the first condition, the price of the mode A here is 50,000. Then the volume of mode A is 600. Volume of Volume of mode B is 900, and volume of mode C is 250, and for the second condition is like this. Okay. We want to calculate the direct and cross elasticities of the volume of the use of these modes with the respect to the fare of mode A. Oh, sorry. And then based on the data, are modes B and C substitutes or complements of mode A? Then we need to explain about it. Okay. You want to calculate the direct elasticity first. So we calculate for the mode A due to change of mode A, change of volume of due to the change of the volume of the price of mode A. So as we can see here, the volume of mode A increases when the price of mode A decreases, and it's logical, right? And then we just calculate the elasticity by using the formula given before. Then we get the result is sorry. Um, we put the x1 here as 50,000 from this one, and then the x2 is this one. What is x1? I just put this the x, and then this one is the key. Okay, it's the x1. Oops, sorry, x1, x2, key1, key2. Just put it into the formula, and then we got this result of minus 83.33%. The direct elasticity of the A yields a negative result, which means it has opposite sign with the variable, and then with the increase of the price, uh, it will lead into the result of the volume of mode A increases. Then the demand change is not elastic because it's still this one. still like this one, okay? From the thing I explained before, it's inelastic. Okay. Then we calculate the cross elasticity for the B and C, for the mode B and C. Just put this formula, then we get the result of 55.55%. And it yields a positive result, which means that the sign is the same as the variable, and then with the increase of the price of mode A will yield into the increase of the volume of the mode B. Then this value is also inelastic. Okay. As for mode C, we get the result of minus 100%, and since sorry, I forgot to put this one. The absolute value of x here is equal to 1. It means that this is unitary elastic. And since the sign is minus, which is different from the variable sign, then with the increase of mode, the price of mode A, it yields the result of the increase of the volume of mode C. Okay. So we can conclude that the type of alternative of mode B and mode C, the mode B is a substitute of the mode A because the the sign from the elasticity of this one, the sign is minus, right? But in the mode B, the sign is plus. So since the sign is different, the mode B is a substitute of the mode A because the decrease of the price of mode A yield the result of the increase of volume of mode A, but the volume of mode B decreases. This thing means that um, these two modes is competing with each other. So, for example, in the real life, uh, it's like two BRTs in the same corridor. Maybe it's like that. So it's competing with each other as substituted. And then the mode C is a complement. Sorry, the mode C is a complement of mode A because the sign is the same, right? This one is minus for mode A, and for the mode C is also minus. So the decrease in price of mode A will into the increase of volume of mode A and also the increase of the volume of mode C. So it has a complementary relationship with each other. For example, in the real life, it's like BRT with its feeder. Okay. That's for the fifth tutorial. Thank you for listening.